1 and A.
And then it takes you somewhere.
A car is traveling so
I
that
was wondering about the
its
links
speed
on the
is never
video.
decreasing during a 12-second interval. The speed at various moments in time is listed in the table below. A graph of the data is also provided. Use three subintervals of equal length to estimate the distance traveled by the car during the 12 seconds by finding the areas of the three rectangles drawn at the heights of left and right. This is called a left Riemann sum.
So for the left Riemann sum, if you say Riemann sum, Riemann, it doesn't matter, Riemann sum. I'm going to go ahead and denote that with yellow if you want to be consistent with mine. Let's kind of recap going back to like physics or even just science in general. To find the distance, what two things did you multiply? The distance is equal to something times time, yes? Speed times the time. In this case, our speed, we're going to call that velocity. So if you want to go to notate in our chart, T and V, you can write it as T, doesn't really matter. And what I want to do is, I want to divide our table into three subintervals. So how many seconds are listed on our table of our X value? And if I want three equal pieces, how many seconds must be in each set? 4 seconds. So let's go ahead and do that on the top. And I'm going to use like a little upside down U. 0 to 4 is 4 seconds, 4 to 8, and 8 to 12. And I'm going to show you visually, but for now I don't want to, because not everything is going to have a graph. So here's our first subinterval. So within this first subinterval, what is the lowest y value given? 5. Because it says to use left Riemann sum, I'm using the leftmost number. So our equation is going to look like 5 times, it is jumping by 4 per interval, so we have times 4. So now let's go to my second subinterval. On our second subinterval, if it will appeal, what is my lowest number or the leftmost number? Did you guys say 21?
That is.
So 21 times 4, and again, it's times 4 because it's going by 4 seconds each time. And my third subinterval, what is my leftmost number? 45. And again, I'm using my left number because it says the left Riemann sums. Is everybody okay with that? In case you're more of a visual learner, although we have a visual table on there, I'm going to go a step further. So on our table, let's go ahead and divide this into three subintervals. And here's the way I'm going to read it. And it would be nice if I can cover everybody else. So look at the first interval. I have left, middle, and right. It says to use left Riemann sum. So let's draw a rectangle from the left. And I'm going to shade it with yellow. And then go to my next subinterval. On my next subinterval, here's my left, middle, and right. So using the left, make your square. And actually, it should be a rectangle. My third one, we have left, middle, and right. And we want the left one again. And I'm only doing this for the visual purpose of our equation that we came up with. To find the area of a rectangle, isn't it length times the width? It is 5 units high and 4 units wide. Do I have that right here? My second one, it is 21 units high and 4 units wide. Do I have that here? My third, 45 units high and 4, and I already have that. So whether you're looking at it from a table or from a graph, that's completely up to you. All right? At some point, I might not even look at the graph. Everyone good on that? All right, let's compute how many we have when I put this in the calculator. So your quiz on Friday, it'll be allowed, your calc. And we're looking at distance, so our answer must be in feet. If you have it computed, just shout it out. 284. All right, Grant, let's read part B.
Using three subintervals of length finding the areas of three rectangles drawn at the heights of the leg endpoints is called the right Riemann sum.
So we're doing the right Riemann sum, and I'm going to denote that with the pink. So let's look at the table first. When I look at the first subinterval, what is the highest number or the rightmost number? 21. So let's go ahead and write on here 21 times 4, and again, it's going up by 4 each time. When I go to my second subinterval, what is my rightmost number? 45. So we have 45 times 4. And of course, the last one has what number? 65. So we have plus 65 times 4. Let's type that in. It has to be a lot bigger than 284 because the right number is bigger. 434? 524. Off by almost 100, right? All right. Now let's look at this visually. All eyes on the board because I'm going to use the same graph. So within the first subinterval, here's my left, middle, right, and we're using right Riemann sum. So this is the whole box right here that I'm going to shade in, or maybe use my diagonal. And then here's my right, all the way down. And my third right. So it's clearly, even by the graph, we know it has to be greater than 284 and a lot greater. So any questions on that? Okay. So my next one, Nick, let's read part C.
Using three subintervals of equal length, estimate the distance traveled by the car during the 12 seconds by finding the areas of three rectangles drawn at the heights of the midpoint of each interval. This is called the midpoint Riemann sum.
So we're doing midpoint Riemann sum. Notice the table is exactly the same as the one above. I get this here on the bottom for convenience, right? So just by looking at this right here on the table, the middle number has to be 12 times how many? 4. It's jumping by 4s. What is my middle number for my next subinterval? 32 times 4 again. What's our last one for the midpoint or mid value? 54. Okay, let's go ahead and compute this one real quick. And it has to be between 284 and 524. Hence the midpoint, right? 3 how many? 92 feet. And keep in mind, we're only approximating. All right? We'll get to the exact value next week. Are you guys okay if I don't draw the graph? It's just going through the middle. Yeah? Okay, let's go on to the next. Third page. Are your names on it? Is this the homework? All right. Will I be checking it for a grade? Most definitely. All right. So for part D, Hamilton, let's read.
Using three subintervals of equal length, estimate the distance traveled by the car during the 12 seconds by finding the areas of three trapezoids drawn over an interval. This is called a trapezoidal Riemann sum.
So we're looking at trapezoidal Riemann sum. Again, it's the same graph or same table as well. Let's do a recap, and I'm going to rotate it a little bit right after. Back in geometry, you had two parallel lines, and those were called base 1 and base 2. And if you don't remember, that's okay. That's why I'm doing a review. And the sides were connected, right, Josiah? And when the two of them were meet perpendicularly, that was our height. But then let's see what it's going to look like for our picture. And let's write the formula first. The formula started with base 1 plus, what do you guys think? Base 2 divided by 2 times the height. So the one that I want to look at is my first interval. So from 0 to 4, I want you to connect your left and right and make your trapezoid. And when I do, you realize the bases that are parallel are now vertical instead of horizontal. Do we all see that? Okay, so that means our height must be the piece that is connecting the base 1 and base 2. So let's apply the formula on this one. How high is my base 1? How many units? 5. How many units high is my base 2? 21 divided by 2 times the 4. So if I specifically look at the table, you'll realize within the first table or first set, the 5 and 21 is simply our left and the right. So if I want to go ahead and look at that pattern without drawing my next trapezoid, what two numbers is my base and the height? 21 and 45 divided by 2 times 4. And then our last piece, what is my base 1 and base 2? 45 and 65 divided by 2 times 4. Let's type that in. And the number has to be in between your left and the right. Or pretty close to the midpoint. For how many? 404 feet. And there's a relevance to this that I'm going to explain in about 2 questions after. In the meantime, let's do E and F at the same time. So Lily, let's read E and F.
Which of your answers is an under approximation? And which of your answers is an over approximation?
And when we say under approximation, when drawn a curvature line, is it less than that amount or over that amount? And I want to do this visually. All I need is 3 rectangles side by side, and we're simply making an approximated drawing of the previous graph. And at this point, what I want you to do is the following. My left Riemann sum was the left point that I used. And then I want you to connect a curved line. It might look straight, and that's okay. So if I want to find the area under that curve, and what I did from left Riemann sum was everything way below. Is that over or under the actual curvature approximation? It is under. So we know this one is going to be, which is under? It is left Riemann sum. And the reason is because the speed, because our speed was our y value, is increasing. If the speed is increasing, my left Riemann sum is always going to be under. Now let's draw another one just like this. And it's okay if it's not perfect. And this time, I want you to put a dot on the right side of each rectangle. And make a curvature, if you will. And if I'm just looking for the area under that curvature, and I happen to find the area of all of these, did I do too little or too less? Or too more? Too much? Too much. So this will be over right Riemann sum. Because of speed, again, it's increasing. So here's what you can anticipate that we are going to cover before the quiz next time. If the speed is decreasing, these are going to be inverted. All right? So if you can see the visual, cool. If not, we'll do some next time. All right? So then, let's look and see what's going to happen if I calculate part A and B. So when I find the average of A and B, my A was left and right. My left Riemann sum was 284. The right one was 524. To find the average of 2 numbers, we divided by 2. How many is that going to give us? You have a calculator in front of you. 404. And I want you guys to see something. Is something relevant here? The trapezoid is the average of the left and the right. Because if you think about it, the left was base 1, the right was base 2, and I add and divided by 2. That's still the trapezoid. So let's write the fact about this. Trapezoid Riemann sum is equivalent to the left plus the right Riemann sum divided by 2, no matter what. So let's say on a quiz or test, you found the left, you found the right, and I asked you for a trapezoid. You don't have to find it in every single interval. Just take those 2 average and divide it by 2. And that's it. Okay? Let's see which answer is the best. I want you to look at the midpoint, trapezoid, left and right. Which 2 numbers are the closest? So what are those? 404 was a trapezoid. What else was the one pretty close to 404? Midpoint. Now, it doesn't mean one is better than the other. Depending on the stats or the number given, one might be closer than the other. And that's all you need to know.